Welcome back. Put your thinking caps on because today we have some tough stuff for you today. Okay, we're going to cover the sum and difference identities, which are pretty advanced identities for trigonometry, especially for an introductory class. I would say that probably, in my opinion anyway, one of the main reasons we're covering these is to review the basic identities, which is what we'll have to know to derive them. Now, I'm about to derive them, and you'll never have to do that, so relax, Francis, okay? But you will have to be able to use them, okay? So, and I want to derive them so you know that I didn't just pull them out of my hat, okay? But let's start with our usual review of last night's homework, okay? Let's see. We'll do 2. Last time we were simplifying some identities using some of the basic identities, and the idea was, first of all, or somewhere in there, to try and change everything into some sine or cosine, okay? Now we've got some things here, right here, that's not a sine or cosine, and that's not a sine or cosine, okay? So now what do? Holy, go to war. Well, let's see. I'm going to take the cosecant, and the cosecant, which is, now you're supposed to memorize this, the cosecant is the hypotenuse over the opposite. Well, that's the reciprocal of the sine, okay? And I'm going to take the tan. We had another identity about the tan to change him into sine and cosine. He was actually the sine over the cosine, okay? And I'm going to do that. I'm going to change him into sines and cosines. The cosecant is 1 over the sine, and the tangent is the sine over the cosine, okay? Now, how does that help me? Well, let's multiply this baby out, okay? This term times this term, distributing the 1 over the sine, is going to give me sine squared over sine. I love that. I know already what I can do with that, okay? Plus, now let's distribute to the other term there. Multiplying out, let's see, in the numerator, I'll get cosine squared and sine, and then the sine cosine in the bottom. Now, let's do some canceling, okay? Well, let's see. That'll cancel, and that'll just leave me with the sine squared divided by the sine will just be sine. What's cancels here? The sines cancel. They're all gone. The cosines cancel, leaving me with a cosine, okay? And then I put in the denominator here, and what sine x plus cosine x over sine x plus cosine x. Anything over itself has got to be 1, okay? And that's the answer in this case. Now, what were we trying to review here? Remember, okay, the idea of not just the nightmare of doing it, but that there are basic identities. One is that there are reciprocal identities. You'll have to know, for instance, that the cosecant is 1 over the sine. That's a reciprocal identity. And the identity of the tangent being the sine over the cosine. Okay? Okay, let's do one more. Look at this one. Now, this one was a little bit tricky in that we weren't supposed to change it right away into sines and cosines. We were supposed to try factoring first. Okay, remember how to factor? I got 4 things here. The first, second, first, and second. And the 2 firsts always multiplied to this guy. So what would multiply to him? Well, cosecant squared times cosecant squared. That's my first guess anyway. And the other 2 always gave me the 3rd term, which is cotangent to the 4th. Pretty good guess is cotangent to the 2nd and cotangent to the 2nd. Okay, now I got to get the signs right. And you could mess up. For instance, I could try plus and plus, but if I multiplied it out, that wouldn't work. Okay, so I admit to my mistake, and I try minus and minus, multiply it out. Part of the game is in factoring is checking it, and if I multiply it out, it works. Okay, now let's start looking at some things. The cosecant, remember from the last problem, is 1 over the sine. The cotangent is, from one of our identities, not the sine over the cosine, but the cosine over the sine. Okay? Now these things are squared, so the cosecant squared is going to be 1 over the sine squared, not 1 over the sine. Okay? And the cotangent squared is going to be not cosine over sine, but cosine squared over sine squared. Okay? Now, since this term is the exact same as this term, we're just going to rock and roll with that again. Okay? Now, looking at this, as an overview, I can see that I have two fractions that have the same denominator. So I can make them into one big fat fraction. 1 minus cosine squared, both of them over sine squared. So I can make that into 1 minus cosine squared over sine squared. Okay? And since the other one's the same, I can just write him. Okay? Now, here's where it gets fancy schmancy. Here's where you're reviewing identities, I believe. Okay? Remember your old buddy, the Pythagorean identity. Sine squared plus cosine squared equals 1. Well, that's going to help me to figure out a substitute for 1 minus cosine squared. If sine squared plus cosine squared equals 1, what is 1 minus cosine squared? Well, it's sine squared. Okay, and I have the same thing over here, sine squared. Well, look at these two fractions. Anything over itself is 1. Same thing here. Anything over itself is 1. So the answer, once again, in this case was 1. Okay, all that work for nothing just to get 1? No. What we were reviewing is, once again, your reciprocal functions, your cotangent function identity, and that Pythagorean identity. You'll need to know that. Okay? Okay, let's basically we're going to get back to our new stuff today, sum difference identities. Okay? But I need to review a little bit more of some of the things that are going to go into that. So let's take a look at this. Okay? The sum and difference identities. The review part. Now this is the stuff you're supposed to know already, so I'm going to go pretty fast, okay? You can stop me for questions, I guess. Raise your hand, cameraman. Okay? Not really. Okay. You're supposed to know that the sum of the angles of any triangle is 180. You're supposed to know the word complementary means angles add up to 90. Okay? So we should be able to find this opposite angle because we know that the two acute angles of any right triangle are complementary. Because we know this and this and this add up to 180, and that's 90 of it. Okay? So these two have to add up to 90. Okay? So I'll give you a second. What do you think that other angle is? Okay? Well, it's 65. Subtracting 25 from 90. That's what it would be with complementary. Subtracting it from 90. That's what you want to remember. Okay? So the two acute angles of any right triangle are complementary. We'll be seeing that in a second. Another thing, speaking of complements, okay, if we want to define this side here, right, remember this one from earlier? There was like a million ways to do it, okay? First of all, we could say that x over 1,002, looking at 58 degrees, what is x? X is the hypotenuse in this case, no matter what. As far as 58 degrees is concerned, 1,002 is his adjacent leg. Okay? And we could solve that equation that way. But there's another way to do it. Okay? If we talk about 32, remember how we could get 32, subtracting 58 from 90? If we talked about that, we could say that 1,002 isn't the adjacent leg, but is relative to 32 going across the triangle, he's the opposite. So you could say that x over 1,002, maybe instead of saying the secant of 58, you could say it's the cosecant of 32, which is the opposite over the hypotenuse. You could do it that way. Okay, let's do another kind of a deal where you could switch them around. What if we add 1,002 on top? Well, as far as 32 is concerned, 32 degrees is concerned, he's the opposite. And the opposite over the hypotenuse is the sine. Okay? Well, what if we talked about 58 degrees? He's no longer the opposite, he's the adjacent. Okay? So he would be the cosine, the adjacent over the hypotenuse of 58 degrees. Now these sets of functions, secant, cosecant, sine, cosine, there's a reason for that. Okay? These are co-functions. Okay? And we know that the sine we're going to need to know, the sine of any angle is the same as the cosine of its complement, or the cosine of 90 minus the angle. Okay, remember 90 minus? And the cosine is the same as the sine of 90 minus the angle. Okay? They're called co-functions, hence the term co. Where did it come from? From complements. Okay? What are the other ones? The tangent is the function of the cotangent, so the tangent is the same as the cotangent of 90 minus an angle, and the cotangent is the same as the tangent of 90 minus an angle. Works both ways. Okay? Same thing with the secant and the cosecant. Okay? So we'll boogie through that. Okay, I'll tell you right now, though, the one you're going to use, or I'm going to use today, that's the most important, is the sine and the cosine. Okay, if you look, that's the ones I'm going to want you to remember. The sine of an angle is the same as the cosine of 90 minus the angle, and we're going to go back and forth. The cosine is the same as the sine of 90 minus the angle. Okay? Now, we're still reviewing now. Hang in there, okay? Okay, here's where it gets ugly. Okay, hang in there. Okay, if we look at a unit circle, remember what a unit circle means? I'll put an angle in a unit circle. That means that the radius of the circle is 1, okay? And we can define the angle in a positive direction here in this way, by putting it in standard position. And there's a point there involved, okay? We're going to talk about that point. Now, that point means xy going over x and up y, okay, that the x side of the triangle, which would be the adjacent leg, right, would be the adjacent leg, would go there, and the y part would go here, which would be, as far as this angle is concerned, would be the opposite leg. Okay, and what would the hypotenuse be? Well, the hypotenuse would be 1, okay? Remember, we have the right angle here, okay? Well, big deal. What does that have to do with anything? Well, the sine then, in terms of x and y, could be defined as, sine being opposite over hypotenuse, could be defined as y over 1, right? Could be, opposite over hypotenuse. Cosine could be adjacent leg over hypotenuse, would be x over 1. Okay, you already knew that, okay? We look at negative angles. That means we're not going like this. We're not going in the positive direction. We're going in the backward, negative direction. Okay? You can still put it there. Okay, just remember that it's a negative angle, and it's in a different quadrant. So what's going to change here is the point's not going to be plus x and y. This goes down, so it's a negative y. Okay? Well, that's not too bad. Let's see. So that means a right angle's still there. It's still an x, but what's different is that that's a negative y. The opposite is negative y in this case. For a negative, it's acute now, for a negative acute angle. Okay? Well, what's going to happen now? We have the sine is going to be still the opposite over the hypotenuse. In this case, negative y over 1. And the cosine, here's something interesting happens and when we go to negative. Okay, note this. The cosine is going to be what? The adjacent, which is still x over 1 plus x over 1. Hasn't changed a bit, has it? Okay? Well, if we start summarizing these things, if you think of minus y over 1, I'm going to get hard here, put on your thinking cap, minus y over 1 being the same as minus y over 1, okay, can't you say that? Then we can say that the sine of a negative angle, which is what we just showed you, minus y over 1 is, okay, is the same as the minus the sine of an angle. Let me say it again. The minus the sine of an angle. In other words, when we get to these fancy calculations, we can take with a sine, we can take, if we have a negative angle, we can take the sine outside. My sine being the negative sign. Okay? What happens with x's? X's doesn't matter. It doesn't matter. It's pretty cool. It's easy with x's. Okay? Since x is the same in quadrant 1 and quadrant 4, okay, it's still positive. It really doesn't matter. If you have the cosine of a negative angle, you can just take the negative away because the negative doesn't do anything. Okay? Even though it's going in a negative direction, it's not going to be negative because x is your man. Okay? So we're going to be using that. We're going to be moving, for a sine, we're going to be moving the negative from inside to outside. And for the cosine, we'll just be taking it away sometimes. So don't think I'm crazy when I do that. Okay? Okay, a couple more things. Okay, here's where you're really going to get a headache here. Okay, let's look at the same deal. Remember that this is a 1 now. Okay, it's important that it's a 1, okay, in this example anyway. Okay, and that the sine is, in this case, y over 1. Y over 1, what is y over 1? Isn't it y? Y over 1 is y. Okay, and the cosine is x over 1, which is known downtown on Friday nights as x. Right? X over 1 is x. Okay, I'm setting you up for this. Okay, hang in there. Couldn't we say, are you ready? Ooh, it's going to hurt. This point, xy, remember what I told you? Y over 1 is the same as y, and x over 1 is the same as x. Couldn't we say that that's the point? Ooh, cosine of an angle, sine of an angle? Couldn't you say, let's do that again. Okay? Because what is x? Or x over 1? Isn't it the same as cosine? What is y? Y over 1 isn't the same as sine. So we could actually say that that is the point, cosine, sine. You could do it, believe it. Okay? And you know what? What's really cool, you can do it anywhere. Okay? If we look at another quadrant. Okay? I'm just going to look at one other quadrant. Okay? Quickly, draw our triangle. Now this is the point negative x, y. Okay? Because in this quadrant, x is negative. But in this quadrant, what is the sign? Well, it's positive y over 1. Okay? And let's get fancy here. In this quadrant, what is the cosine? Well, the cosine is negative. The cosine is negative x over 1. But hi, Mom. It's negative x anyway. And this works for any quadrant. So couldn't we say, that being 1, the sine being y, or y over 1, and the cosine being negative x over 1, or couldn't you say negative x? You could say negative x instead of negative x over 1. So this point out here, instead of saying negative x, y, couldn't we say it's cosine sine? Because cosine, that is negative x, and sine is y, or plus y. Okay, so I'm going to be doing those changes, so don't get mad at me. Okay? Okay, one last thing of review. The Pythagorean theorem. Okay, whenever we try and find a distance, diagonal distance especially, don't forget that a squared plus b squared equals c squared. Okay, going fast with that. Okay? We're going to be measuring distances with that. Okay? For instance, if I wanted to know this distance, I'd say 1 squared plus 2 squared equals this hypotenuse squared. Let's see, 1 squared is 1, 2 squared is 4. So 5 is this bad boy squared. Now, how am I going to find out what the answer is? Well, what number squared is 5? The square root of 5. Which, if you use your calculator, you could get something. 2 point, something. Okay? So we're not going to use the calculator here, but you could, is the point. So that's just reviewing your Pythagorean theorem. Okay? Okay. Here's the new part. Okay? Ooh, you're supposed to know all that stuff. Don't forget it. The sum difference identities. Okay? And remember, the reason, I would say the reason we're doing this is to review those things. Let's see how we can use them in these identities. Okay? Okay, we're going to consider, as I say difference, we're going to subtract two angles. One of them is going to be this angle I'm going to call alpha. Okay? You call it the green angle. Okay? And another one, we'll use this point. Let's see. Well, remember what that point could be called. Couldn't it be called cosine of alpha, sine of alpha, instead of xy? That's what I want to do. Okay? And I have this other angle. We'll call it beta. Okay, and he has his point. And what would that point be? Well, that would be cosine of beta, sine of beta, instead of x and y. Okay, because they're different x's and y's. Okay? Well, I told you we could do this. Okay? Now, what we want to do is consider subtracting one from the other, getting this space in the middle, which we'll call S, capital S. Okay? We're going to subtract A minus B, or alpha minus beta, and get S. Okay? That's our deal. That's what we want to try to do. Okay, let's see what's going to happen. I want you also to consider the distance, this distance here, from here to here. Now, how do we measure that distance? We use, as I told you before, the Pythagorean theorem. Don't get nervous. Don't get nervous. Pythagorean theorem. I need him to be the hypotenuse. So let me make a triangle. See the triangle? I'm going to make a triangle and use the Pythagorean theorem. Now, let's see. I need the distances of the legs squared. This distance is the difference in the y-coordinate of this point minus the difference in, minus this one here. And it doesn't really matter which one I put first, alpha minus beta or beta minus alpha, because distance can never be negative. So don't worry about that, okay? So couldn't you say that this distance is sine of alpha minus sine of beta? And then what about this leg here? That's going to be the differences in the two x-coordinates, which is one of them is cosine beta, one of them is cosine alpha. So we'll go cosine alpha minus cosine beta. So that's what that is. Okay, that leg there. Oof. Okay, well, we got to use a Pythagorean theorem. Okay, so distance squared is going to equal this leg squared plus this leg squared. Okay, that's a theorem that we could use, couldn't we? We sure could. Okay, let's try it. Sine of alpha minus sine of beta plus cosine of alpha minus cosine of beta squared is what distance squared equals. Okay, well, let's try and simplify this. I'm going to multiply this out. That's itself sine of alpha minus sine of beta times sine of alpha minus beta. Okay, plus the other two, this one multiplied by itself. Okay, let's do some distribution. This times this is sine squared. Sine squared times him is sine sine. Sine of beta times sine of alpha, we get another one. And then we still have to do the two sines of beta. And we get sine squared of beta. Okay, we're only halfway home. What a nightmare. Hang with me. You'll never have to do this. Just pay attention, okay? Now we've got to do this one. Cosine times cosine. That'll give me cosine squared of alpha. Cosine times cosine. That's a negative. Okay, positive times a negative. Now I'm done with him. Now you. Okay, minus cosine of beta, cosine of alpha. I get that. And then I got one more left. Minus cosine of beta times cosine of beta. Now that's a negative times a negative, so I get a positive. Okay, now let's start arranging things. Okay? I take the sine of alpha squared. Oh no, I'm going to put these two together. Okay, we'll put these two together and get two of them. Minus 2 sine of alpha sine of beta. Okay? And then I've got my sine squared. And I got my cosine squared. And I see I'm going to put these two together. And I'll get two of them. And then I'll get my cosine squared. Okay? What can we do with this now? Ugh. Well, can't we take this and put them right next to each other? They love each other. You love sine squared, cosine squared. Okay? And I'm going to put these two next to each other. I bet you know what I'm going to do later. And then we'll write this other garbage. Okay? Not too much we can do with that, those other two. Okay, now why did I write these two next to each other? What is sine squared plus cosine squared? That's 1. And what's the other sine squared plus cosine squared? That is also 1. Okay? And then I think what we can do is factor a 2 out of these two. And I'll have minus 2 times all this garbage. Okay? Now if we put that 1 and that 2 together, I'm sorry, the 1 and the 1 together, I'll get a 2, and then minus 2 cosine blah, 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 blah. Okay? Minus 2 cosine alpha, cosine beta, sine of alpha, sine of beta. Okay? So that's as small as I can get in this example so far. Hang with me. I know it's hard. Okay, hang there. And we're going to re-look at this whole thing. Okay, so far we've got that much. Okay, now we're just going to consider angle S. But you know what we're going to see how angle S is? Angle S, which was alpha minus beta. Okay? Which has the same distance. But before we do it, we're going to rotate him so that he's sitting flat on the x-axis. Okay? There we go. We rotated him. Okay? Now he's got his point. Just forget the other angles. He's got his point, which is cosine of S, sine of S. Okay? And we'll look at the same distance. Okay? Now let's make a triangle for this. Let's see. Here's a triangle. Okay, now I've got 2 points here. I've got the point cosine S, sine S, and I've got the point 1, 0. Where did I get the 1, 0? Well, this is a unit circle, so that's 1, and it's up none. Okay? So I'm going to use this distance. I'm going to use my Pythagorean theorem. This distance here is the height, or the y, is sine of S. It's just sine of S, minus 0. Okay? And this distance here is cosine of S. That's the x part of this point minus the x part of this point minus 1. And remember, it doesn't matter which comes first because distance can never be negative. Okay? And we'll do all the squaring. Distance squared is going to equal one of the sides squared plus the other side squared. Okay? Now let's try and simplify that. Okay? We got the first term squared plus the second term squared. Okay? Now let's distribute out. And basically, I'm going to get sine s squared. Now, the zeros are going to go away, of course. Okay? Now, let's go cosine times cosine. Cosine times minus 1. Minus 1 times cosine. And then minus 1 times minus 1. Okay? When we simplify this at all, I see my buddy's sine squared and cosine squared. I love that. So that'll become 1. I think I can put these two together and get 2 of them. Okay? And then I've got my 1. So those two 1s, I guess, we'll put together. Okay? And then bring u down. Okay. But remember, so that's what we got. That's as far as we got doing that. But remember, distance squared, the same distance, same angle s, also equals all this garbage. Okay? Well, let's set the two equal. They're the same thing, distance squared and distance squared. So we're trying to get a theorem out of this. Okay? If these two are the same thing, these two are the same thing, and this equals this, and this equals this, then all this equals all this. Let's set those two equal. Put him down here and him down here. And let's see what we can do with it. First of all, let's subtract 2 from both sides. And then let's divide everybody by negative 2, because they're both divisible nice and evenly. And it would appear that the cosine of s is the same as cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. Okay? Well, what is s anyway? S is alpha minus beta. Okay? Now what we were going to talk about here is the difference of two angles. And that's what S is. It's the difference of two angles. So we have, believe it or not, you're not going to like it, we have a theorem here. The cosine of the difference of two angles is equal to the cosine of one of the angles times the cosine of the other angle plus the sine of one of the angles times the sine of the other angle. And that's called the cosine difference of two angles identity. Okay? We're going to try the same derivation for the cosine of the sum of two angles. Okay? You can forget about S now. We're done with him. This was the difference theorem, right? This was the difference identity. Couldn't we say that the cosine of the sum of two angles is the same as the cosine of subtracting a negative? Isn't adding, subtracting a negative? Okay? Why would I want to do that? Because I have a difference theorem. I'm trying to make it into a subtraction problem is what I'm doing. Okay? Well, so I'm going to fill this theorem, and instead of writing cosine of beta, I'm going to write cosine of negative beta. Okay? Same theorem, I'm going to replace it. Okay? Instead of cosine beta, I wrote cosine of negative beta and sine of negative beta. Okay? Well, how does that change? Remember that cosine of negative beta, you can just take the negative away. Remember we talked about that earlier? You can just take negative away with the cosine. And what could you do with the sine? The sine, we couldn't take it away, but we could bring it out front. Okay? So what we're going to do is now we have the real theorem of the cosine of two angles added. What's going to happen here is, oops, let me go back. This is the theorem for the sum of the two angles. I've got very similar, except that cosine right here, I just took it away. Okay, and what happened to him? What happened to him? I brought him out front. Oh, he jumped over, and he went to there. So now we have the cosine sum of two angles identity, and that's in your notes. You don't have to write it down. Get it all for you. Okay? Okay, now, remember, I didn't tell you this for laughs, this idea of cofunctions and the complements of angles. Okay, the sine of an angle is the same as the cosine of 90 minus an angle, and the cosine of an angle is the same as the sine of 90 minus an angle. So from this one, we can actually derive the sine of the sum, S-U-M, sum of two angles. Let's take a look at it. Okay, the sine of alpha plus beta. Well, we're always trying to get back to a theorem that we've already proven. Okay, and we're going to try and get back to the cosine of the difference theorem of the cosine. Okay, well that's why I told you. The sum, the sine of angles of an angle is the same as the cosine of 90 minus the angle. So that's what we're going to use that theorem. Okay, the cosine, the angle we're using here is alpha plus beta. Okay, It's the same as the cosine of 90 minus alpha plus beta. Okay? Well, let's see. Cosine of 90 minus alpha plus beta is the cosine of 90 minus alpha, distributing this, minus beta. Or 90 minus alpha as one animal minus beta. Okay, so we'll have two angles subtracted, one of them being 90 minus alpha and the other one being beta. Okay? Well, we have a cosine difference identity. Okay, and that's what this is. So let's take this angle, 90 minus alpha, and substitute it in here. And let's take this angle, beta, and substitute it in here. Okay, let's see what happens. We're supposed to take the cosine of our angle, cosine of 90 minus alpha. Oh, we just put the cosine of it, that's in. And then plus the sine of 90 minus alpha and beta. Now what can we say instead of this? What is the instead of the cosine of 90? Isn't that the same as the sine of alpha? Okay, and what can we say instead of this? Isn't that the same as the cosine of alpha? Well, get out of this town. Now you actually have a theorem for the sum of two angles using the sine. Okay, and that's what that is, and that's in your notes, and that's where that came from. Okay, I'm going fast, I know. Okay? Okay, is there one more? There's going to be in this case, the sine of the difference of two angles. We've done the difference for the cosine and the sum for the cosine and the sum for the sine. Let's do the difference, okay? Well, let's see. Let's turn it into one of the ones we already know. The sine of alpha minus beta is the same as the sine of alpha plus negative beta. When you add, when you subtract things, it's the same as adding the opposite, right? Okay? So let's see. We have the theorem for the sum, so let's replace into the sum the negative of beta. Okay, let's see what happens. Putting into the theorem, instead of beta, we have a negative beta. So every place there's a beta, I put a negative beta. Every place there's a beta, I put a negative beta. Okay, now what can I replace here? Okay, let's see. Remember what we can do with a sine? We can take the negative and bring it out front. Okay? And what can we do with a cosine? We can just take the negative away. Okay? So considering that, we can take this. What can we do with this negative? Just take it away. And this negative, we can bring it out front. And I think we're going to get this theorem here. I got the sine's the same. The cosine, I just took the negative away. The cosine, he's the same. And the sine, I brought this negative to the front, and that's where that subtraction came from. Okay, see? Okay, now what are we going to use this for? Okay, here's some of the homework problems. He needs you to evaluate the cosine of 105 degrees. You have to pretend that you're Socrates or somebody and you don't have a calculator, okay? You're drawing in the dirt, okay? Well, it's going to have to do something with one of these theorems, okay? Well, this one is, I'm giving you a hint here, is the cosine of two angles added. What two angles that we know the cosine of, add up to 105 degrees? Well, in this example, 45 and 60 add up to 105 degrees. Now, how do we know 45 and 60? Remember, we know by the Pythagorean theorem, okay? We knew any 30, 60, 90 triangle was in this ratio. We had covered that. And so you're supposed to, if you know that it's in that ratio, you could find, you know, without even a calculator, you could find the sine, cosine, and or any other function thereof of 60 or 30, okay? You could even do the same thing using a 45, 45, 90 triangle for any multiple of 45, okay? So we're always looking for 45s and 60s and 30s, okay? So anyway, getting back to our problem, knowing that we can't find 105 directly, but we can find 45 and we can find 60, let's put it into the theorem, okay? The cosine of 105, known downtown as the cosine of 45 plus 60, is going to be, using our theorem, plugging, instead of alpha we put 45, and instead of beta we put 60. The cosine of 45 times the cosine of 60 minus the sine of 45 and the sine of 60. Now the hard part was you had to figure out which was the right theorem, okay? Anyway, once we put those right numbers in, can you say, oh, you just use your calculator? Well, that's not the idea. You're not supposed to just use your calculator. You're supposed to go ahead and multiply these out, okay, and figure out what that is. And son of a gun, when you multiply them out and you do the subtraction, you get negative 0.2587. Okay, so we could have actually figured out that, and in this case they're asking me to evaluate it, not simplify it, so that was the answer, negative 0.2587. Okay, here's another one. We're supposed to simplify or evaluate all this nightmare. Now you're supposed to cosine cosine minus the sine sine. Now these two angles, 4218, 4218. That, I hope, looks like one of the theorems. One of the theorems, if you look in your notes, goes cosine cosine minus sine sine. You have to find it. You have to know your theorems, okay? Guess what? It's the cosine sum of two angles. Cosine cosine, sine sine. So we could go backwards in this case, okay? We want to know what all this is equal to. In this case, I think we're going to simplify. We're not going to evaluate. We're going to simplify. Is going to be the same as the cosine of the sum of these two. The sum of 42 and 18, you love the sum of 42 and 18, okay? It's 60. It's always going to come out nice. It's going to come out nice in the homework too, so don't worry. Okay, and we know the cosine of 60, okay? It's 0.5, okay? So that's what, and what they're asking you to do there in this exercise is to get to know your theorem. Okay, and to pick which one. You only had 4 at that point. Okay? In this case, we asked you to evaluate it. That's where it came from, 0.5. Do one more. In this case, look at which function goes cosine cosine, sine sine. Okay, when the angle are the same in the first case. Well, in this case, it's going to be the cosine difference identity, where it goes cosine cosine, sine sine. Okay, and in this case, alpha, as you can see, is 41, and beta is 17. So we're doing the difference of 41 and 17, hoping that it's something, you know, that we know. What is 41 minus 17? Well, it's 24. Okay. Now, they're not asking you, in this case, well, you couldn't, the idea is, since you don't know the cosine of 24 without a calculator, you're just going to simplify it, and that is it. That's it, simplified. Okay? If they asked you to evaluate it, then you'd have to actually give them a decimal answer. So there's a difference between the directions. Okay? Okay, here's a hard one. Here's a real hard one. I want you to tell me, given the sine of u is 5/13 and the sine of v is 12/13, I want to know the cosine of u plus v. Okay? Well, gosh. To do that, I can go right to the theorem, the cosine sum of two angles theorem, but I need to know 4 things. I need to know the cosine of alpha, the cosine of beta, the sine of alpha, and the sine of beta, and I really only know the 2 sines. So before I can even do this, I have to know the cosine. Okay? So what are we going to have to do? I don't know that. I need to know all 4. Well, here's the deal. Here's a trick. Remember the Pythagorean identity. Sine squared plus cosine squared equals 1. Okay? Well, if we know the sine of an angle, we can figure out the cosine. You know how? We know by the Pythagorean theorem the sine squared plus what we want to know, the cosine squared, is 1. Okay? Well, let's solve that equation for the question mark. Okay? In this case, we know the sine of u is 5/13. So the sine squared, I'm sorry, what am I doing here? Sine is 5/13, so I'm going to add the 2. In this case, I'm going to subtract 5/13 squared from both sides of the equation. Okay, and I'll have my answer squared. Well, 5/13 squared is 25 1/69. Now let's do this subtraction. 1 is 169 1/69. Okay, I just got a common denominator there. Subtract 25 1/69, and I get, a beautiful number, 144 1/69. And that's what I want to know squared. So that leads me to believe that the cosine of u is 12/13. Now, where did I get that? Holy go to war. What I wanted to know was the cosine of u. What I did was I took the square root. I took the square root of this, and the square root of what I want to know. So I know the square root of 144 1/69 is nicely 12/13. Okay? Now, I still have one more to find. I know the sine of v, it's going to work the exact same way. The sine of v is 12/13. I need to know the cosine of v. Well, I'll use my Pythagorean identity. Okay, let's see. Let's subtract sine squared from both. No, we're not going to do that yet. We're going to substitute in that we know that the sine of v is 12/13. Okay, now subtract it from both sides. Okay, get a common denominator, I guess. We're multiplying it out, 169. And subtract. And I get 25 169ths. And apparently what I'm looking for here, the cosine of v, is the square root of both sides. So that's going to be 5/13. Okay? Now, ooh, this is a serious problem. Now I know the sine of u is 5/13, the cosine of u is 12/13, the sine of v is 12/13, and the cosine of v is 5. So I know them all. So I'm ready to rock using the theorem. Okay? The cosine of the two added up. Using my theorem, all I have to do is substitute the numbers in the right place. Well, let's see. It's going to be 12/13 for the cosine of u, 5/13 for the cosine of v, and substituting in, I multiply out, I get 61/69 minus 61/69, and all this, guess what, gives me 0. Okay? What were we doing this for? To review the Pythagorean identity. As you can see, as I said at the beginning, you're reviewing basic identities doing this. Okay? Okay, well now, what I suggest you to do is try homework 9. You might want to turn the tape off. There's more to come on this tape, however, today. Okay, so don't lose me, and don't stop recording. Okay? Okay, let's see how the tangent fits into this. Okay? Consider the difference identities for the tangent. Okay? Well, as always, we're going to try and turn the tangent into sines and cosines. Okay? Remember that the tangent, by definition, is opposite over adjacent. And if we had a little trick earlier, if we divide top and bottom of that by hypotenuse, we've got the opposite over the hypotenuse divided by the adjacent over the hypotenuse. We could really say that the tangent is the sine over the cosine. We've done that before. We did it for last night's homework. Okay? So we're going to be doing that. Okay, so let's try and derive a fancy formula for this one. Okay? Considering the tangent is the sine over the cosine. Well, if we want to know the tangent of alpha minus beta, we could say it's the sine of alpha minus beta over the cosine of alpha minus beta, using that same identity. Okay? Now we've got theorems for the sine of alpha minus beta and the cosine of alpha minus beta. So I take all this garbage and put it in the top, and all this garbage and put it in the bottom, and I almost have a theorem. Okay? You might even say. Okay, well, let's see if we can simplify it a little bit more. Okay? Now, as I said, if you look at your notes, there's a theorem for the sine of alpha minus beta and the cosine of alpha minus beta. Okay? And there they are. That's what I'm going to put instead of that. And instead of this, I'm going to put his theorem. Okay? That's my goal. And if I put that in, I get all this stuff. Okay? Let me see if I can manipulate that a little bit and make it not quite as much of a nightmare. Okay? Here's what we're starting with, right here. Okay? I'm going to, now you'll never have to do this, but I'm going to divide everything by cosine of alpha, cosine of beta, top and bottom. And I'm not breaking any laws, because as long as I divide the top and bottom of a fraction by the same thing, I'm really dividing by 1. And you can do that anytime you want. Okay? So that's what I'm going to do. Let's take a look, see what it becomes. Okay, all this divided by cosine of alpha, cosine of beta. It's going to be that divided by cosine alpha, cosine beta. That's the first part. Minus the second part divided by cosine alpha, cosine beta, over this part divided by cosine alpha, cosine beta, plus this part divided by cosine alpha, cosine beta. Well, let's see. We have any cancellation? Phew, good. Okay. Got cancellation like a mug down here. That cancels, that cancels. That, if everything cancels, what do you have? 1. Okay, and then in here, I don't see too much canceling there. But let's go backwards now. Okay? Up here, sine over cosine minus what's left over here? Sine over cosine of beta. Okay? Then right here, I have 1. And then what do we have here? Plus sine over cosine of alpha and sine over cosine of beta. Okay, now what do we know about sine over cosine? We said before, we can simplify this even further should we choose to. Okay? Instead of writing sine of alpha over cosine of alpha, I'm going to write tan of alpha. That's an identity that I can use. Minus, what am I going to write instead of this? Tan of beta. 1's my buddy. I always love 1. Okay, plus, now I got two tangents here, really. The tan of alpha and the tan of beta. And believe it or not, hot-cha-cha, that is your tan difference of two angles identity. Okay? And that's where it comes from. We're going to do the plus. There's only one more left. Hang in there. And what did we do with the plus, with the sines and the cosine? Well, we made it the plus of a minus, so that's what we're about to do. Let's change the tangent of alpha plus beta into a bunch of sines, sines over cosines. Okay? And we have a theorem for this. We have a theorem for the sine of alpha plus beta, and we have a theorem for the cosine of alpha plus beta. Okay? And I've already substituted them in quickly. Okay? I'm going to play my same game, dividing by cosine alpha, cosine beta, on top and bottom, which I'm allowed to do because I'm really dividing by 1. And rushing through this. And now let's cancel. And cancel like a mug. I'm going to get the sine over cosine of alpha plus sine over cosine of beta over 1 minus sine over cosine of alpha, sine over cosine of beta. Okay, and it looks very much like the last theorem, doesn't it? Okay. We can replace backward just like we just did. This will become tan of alpha. This will become tan of beta. 1's your old buddy. This will become, once again, tan of alpha and tan of beta. And that is your tan sum of two angles identity. Okay? And what can we use that for? Let's get some problems. Evaluate the tan of 15. I got to do the tan of 15. We don't know the tan of 15. We got to find angles that we do know that either add up to 15 or subtract to 15. Okay? Well, we know 60 and we know 45. Okay? And 60 minus 45 is 15. Okay? So you're always looking for things that you know. Remember, we know the tan of 60 because of our 30, 60, 90 triangle. Okay? We could figure it out just doing the division. Would be for 60 would be the square root of 3 over 2, and it'll come out. You could do it. You don't even need, certainly don't need a calculator. Plato didn't need a calculator. Okay? And with the 45 triangle and a Pythagorean theorem, you may remember, just review, that we had the square root of 2 here. Okay? So that the tan of 45, no matter what you're looking at, is opposite over adjacent is 1 over 1 is 1. Okay? So to evaluate this, just putting it into the theorem, a tan of 15 is the tan of 60 minus 45. And we're doing which theorem? We're doing the tangent difference theorem. Okay? So we'll put the tan of 60 minus the tan of 45, just substituting into the theorem, 1 plus tan of 60, tan of 45. Okay, let's substitute the numbers in, do the calculations, and hi, Mom. Now, you didn't need a calculator. You could use a calculator, but you didn't need one, is the point. Okay? Okay, what about, and this was very much like the last one in the last class, okay? The sine of u is 5/13, the sine of v is 12/13, and they want to evaluate the tan of u and v. Well, you can't even find the tan until you know the cosines of these things, because remember, the tan is the sine over the cosine. Okay, so we're going to have to find the cosines of u and the cosine of v first. Okay, and remember the trick we used for that? It was the Pythagorean identity. Okay, once you know the sine of something, you can find the cosine of it, and vice versa. Okay, let's do it. We know the sine of u is 5/13, and we want to know the cosine of u. Okay, u. Yep. Okay, let's see. The sine squared of u, this is a Pythagorean identity. Sine squared plus cosine squared is 1. That's my unknown there. Sine squared plus cosine squared is 1. Okay. Okay, let's put our 5/13, which we do know, and the other one we don't know. Okay. Now I'm going to subtract 5/13 from both sides of that equation. Okay. and square it. 5/13 squared is 25 1/69. Okay, now how am I going to subtract 25 1/69 from 1? I guess I'll change 1 into the way he dresses up on Friday night, 169 1/69. Okay, now I can do the subtraction, and I get 144 1/69. But that's not the cosine of u. That's the cosine squared of u. I don't want to know the cosine squared of u. I want to know the cosine of u. So I take the square root of both sides, which square root of this is u, square root of cosine u, and square root of this is 12/13. So I know the cosine of u. Let's play the same game quickly with the sine of v. The sine squared of v plus the cosine squared is 1. Okay? Well, I know it's 12/13, so let's put it in. Okay, subtract it from 1. Actually do the multiplication. Okay, get a common denominator and subtract, and I get 25 1/69. I'm really happy that I got 25 1/69. It comes out nice. It may not always come out nice, but I still could take the square root of it. It may not be as easy, but I could still do it without a calculator is the point. Okay. And now I'm going to have to take the square root because of both sides to solve for the unknown. And I'll now have everything I need to know. I have both sines and both cosines. Okay? Now how does that help me with this problem? I've got the cosine and the sine. So what does that make the tangent here? Well, the tangent is the sine over the cosine. 5/13 over 12/13. I now know the tangent of u. Okay? Because I knew what the cosine and the sine were. And the sine and the cosine of v I know. So I can figure out the tangent of v. Remember, the tangent is the sine over the cosine. So it would be dividing 12/13 divided by 5/13 be 12/5. So now I know both the tangent of u and the tangent of v, and I can plug it into the formula of the difference of two angles for the tangent, which is this. And all he needs to know is the tangent of the two, and I plug it in. Let's do it. The tangent of u 5/12 minus 12/5. 1 is part of the formula, and then I multiply these out. Okay, and that's going to be, this is 1 in the bottom there. 5/12 minus 12/5 is, negative 1/19 over 60 divided by 2, and I get negative 1/19 over 120. Now you can do that on the calculator if you wish, but the neat part is you didn't need to. Okay, you never needed a calculator. That's the answer. Okay, at this point, it's homework time for this time. It's just more practice of the same. You learn way more by doing, which is why I give you credit for homework. Okay? So I'm going to have you do homework 10 now. Okay? Very much like the earlier homework, except in this case you're only recognizing the tangent difference in some functions and putting them either forwards or backwards, putting them into play. Okay? Now if you have trouble with that, remember that you can go out on the home page, and I have the answers and the way that you get them. You have access to that. And you can also have access to email me if you have problems with that. Okay? And if you want to view this class, remember that you can go to class animations and view it, but probably just need to look at your notes, which I gave you the first day. Okay? So till next time, do your homework. We'll see you then.